Okay, hello again, class. This third video replaces our session today in which we had to go over chapter 14 and review for final exam. I selected a few questions for you in chapter 14 to go about solving different possible questions that you might see in your final exam. So let's get started with the first one. A hat maker fresh off a very successful showing at Leeds-a-Palooza is excited about the prospect of providing the finest chapeaus to meet the need of his energized customer base in the coming year. He and his space designer have identified 7 activities that are necessary to expand his small shop. For the sake of simplicity and to avoid giving away any trade secrets, the activities have been identified by letters A to G. The activities, their time estimates, and the precedence requirements structure are listed in the table immediately below. Use this table to answer the following questions. Okay, so we can see that we have here our activities and their predecessors and time that each activity will take. First question basically here says that refer to the scenario above, develop a Gantt chart for this project and indicate the finish time for each activity. Okay, so we need to go ahead and build a Gantt chart for this question. So let's use this area here. I copied the table and put it here so I can use it. Let's make it a little smaller so we can use the real estate a little more efficiently. Remember we solved a similar example of building a Gantt chart in class. I also introduced an Excel template to build a Gantt chart with, but for the sake of this question and mainly for those questions that you might see in your final exam, it is okay if we just do it manually. So first let's build our Cartesian set. Basically on the y-axis we have different activities, and on the x-axis we will have our time. Okay, so here I have time and here I have different activities. Okay, so let's get started. Activity A can start without any predecessors and it takes 7 weeks to finish. So remember that in a Gantt chart we show activities with a little bar. This is activity A, which takes 7 weeks. So if we start here from 0, this end at 7. Activity B, as you can see, starts right after A, and it takes 6 weeks to finish. So it should start here and go for 6 weeks. So it should be a little smaller than A. So this is my activity B, which takes 6 weeks. And since it starts at week 7 and the length of this activity is, or duration of this activity is 6 plus 7 gives me 13. Activity C also starts right after A and it takes 10 weeks to finish. So I started here again and it's going to be 10 weeks. So C, and the duration is 10. So since it starts at 7 and the duration is 10, it will finish at week 17. Activity D can start after activity C and it takes 12 weeks to finish. So I started right after C and I go for about 12 weeks. So this is my activity D and it takes 12 weeks. Since it starts at week 17 and the duration is 12, it finishes at week 29. 17 plus 12 gives me 29. Then I have activity E that starts after B and C and goes for 5 weeks. So B and C means that it should start after C because C is longer. So basically it could start at the same time that D starts. E starts right after B and C, which means C, and it goes for 5 weeks. Oops. So it starts right here and goes for about 5 weeks. So this is my activity E, 5 weeks. Since it starts at week 17 and goes for 5 weeks, the finish time is 23. Then I have activity F that starts after D and E. Again, you see that D finishes later than E, so D and E meaning D and E is basically D. So F can start right after D and it goes for 11 weeks. So this is my activity F that starts after D or E, or essentially after D, and goes for 11 weeks. So this is F with 11 since it starts at week 29 and goes for 11 weeks. The finish time is going to be 40. So 29 plus 11 will give me 40. And finally, activity G that starts after D and F. Okay, G starts after D and F and goes for 8 weeks. So D and F, meaning, let me move this around so we can see it while we are building the Gantt chart. So you see that activity G can start after D and F. F is longer than, finishes later than D, so it means that it can start after F, and the duration is 8. So starts here and goes for about 8 weeks. C, G, and 8. And since it starts at week 40 and goes for 8 weeks, the finish time here is going to be 48. Okay, so this is basically a simple Gantt chart that shows all the durations and the sequence of activities for question number 1. Okay, now let's take a look at question number 2. It says that refer to the scenario above. What are the earliest and latest start and finish times for all these activities? So basically we are calculating the early start and early finishes and late start and late finishes. Remember, for doing that, we need to build the network diagram and do the forward pass and backward pass. So, okay, so let's use this area to build our network. Again, I have a copy of this precedence diagram, not to shift left and right all the time. So let's get started with building this network. As you can see, activity E is the only activity that can start without any predecessors. So if I go ahead and show it with a circle and put the duration also in, and then after doing activity A, I can go ahead and do activity B and C. So this is activity B that takes 6 weeks, and this is activity C that takes 10 weeks to finish. And then after doing activity C, I can do activity D. So this is how I'm going to show activity D, and it takes 12 weeks to finish. And after doing activity B and C, I can do activity E. So this is B and C, and activity E, the duration here is 5. After doing D and E, I can do activity F, which takes 11 weeks to finish. And after doing D and F, I can do activity G. So this is how I'm going to show it. And activity G will take 8 weeks. So now that I built my network, I should go ahead and do the forward pass and backward pass. The earliest start here is 0, and 0 plus 7 will give me 7 for the early finish of activity A. Since the early finish of activity A is 7, earliest start for B and C would be 7. 7 plus 6 will give me 13 as the early finish for activity B, and 7 plus 10 will give me 17 as the early finish for activity C. Between 13 and 17, I take the maximum as the earliest start of activity E, and 17 plus 5 gives me 22 for early finish of activity E. Early start of activity D would be 17, and 17 plus 12 will give me 29 here. Between 29 and 22, I select 29 as the earliest start. Remember, in going forward, I take the maximum. Going backward, I take the minimums. 29 would be earliest start of F, and 29 plus 11 will give me 14. Between 14 and 29, I take 4D and 29, I take 40 as the earliest start of G, and the early finish would be 48. Now let's do the backward pass. 48 is the late finish of activity G, and 48 minus 8 will give me 40 as the late start of activity G. So therefore, the late start for activity, late finish for activity F would be 40. 40 minus 11 will give me 29. Between 29 and 40, I get the minimum. Going backward, we select minimums. 29 as the late finish for activity D. 29 minus 12 will give me 17. Late finish for E as well would be 29. 29 minus 5 will give me 24. Between 24 and 17, I select 17 as the late finish for C. 17 minus 10 will give me 7 as the late start for S. And the late finish for B is going to be 24. 24 minus 6 will give me 18. And among 18 and 7, again, I select the minimum. The minimum is going to be 7 here. And the late start for A is going to be 0. So basically at this point, I answered all the questions. I have all the early starts, early finishes, late start, and late finishes. But just for the sake of finishing the question, let's calculate slack as well. You see that here I don't have any slack. I have no slack here. All the late start and early start and late finish and early finish are equal. I don't have any slack here as well. No slack here and no slack here. So my critical path would be A, C, D, F, G, and the duration would be 48. Okay, so this concludes question number 1. Let's move to 1 and 2. Let's move to question number 3 and take a look at that question. Question 3 says that a project is composed of 12 activities shown in the table. What are the earliest and latest start time for each of these activities? Okay, so this is a simple network diagram that we have to build and do a forward pass and backward pass. Let's take a stab at it and see if we can solve this problem. Again, I copied the table, the precedence diagram here, so we can use it and not pan back and forth all the time. Let's go ahead and start building this network. Again, you can see that the only activity that can start without a predecessor is activity A. So this is how I show it, A with 3 days time. After doing A, I can do activities B and C. So this is my activity B, and it will take 3 weeks. This is my activity C, and activity C will take 15 days to finish. Activity D can start after activity B, so this is how I'm gonna show it. And the duration for D is 2 days. Activity E also can start right after B, so this is activity E, and it takes 12 weeks to finish. After doing activity C, you can see that I can do activities F and G. Okay, so this is my activity F, and this is my activity G. The duration for these two is 16 and 2. Then you can see that after doing activities E and F, I can do activity H. So activity H with duration of 11 starts after activities E and F. So this is how I'm going to show it. This is my activity H, and the duration is 11. Then you can see that activity I starts after activity D and G. Okay, so this is going to be how I'm going to show it. This is activity G. I'm sorry, this is activity I that can start after D and G, and the duration is going to be 9 weeks or days. And then next activity is activity J that can start after D and E, and it takes 6 weeks. So after D and E, and it takes 6 weeks. And after that, I have activity K that can start after H and I. So activities H and I will give me activity K, and the duration is 15. So K with the 15. And my final activity is activity L that can start after J and K. So J and K will give me activity L, and that will take 13 weeks. So this is my network. It's a little more complicated than the previous networks that we saw, but it's not going to be an issue. We can just go ahead and apply the same method to calculate the forward pass and backward pass. To perform the forward pass and backward pass and calculate the earliest starts, early finishes, late start, and late finishes. Okay, so let's get started here. Earliest start here is 0. 0 plus 3 gives me 3. Earliest start here for B and C would be 3. Early finish would be 6 for B and 18 for C. Early start for D and E would be 6. 6 plus 2 gives me 8 for early finish of activity D. And 6 plus 12 gives me 18 for the early finish of activity E. Early start for F and G would be 18. 18 plus 16 will give me 34 for early finish of activity F, and 18 plus 2 is 20. Since D and E are the predecessors for J, between 8 and 18, I select 18 as the earliest start for J, and 18 plus 6 will give me 24. Between 18 and 34 for H, I take 34 as the earliest start, and early finish would be 45. Then for I, between 8 and 20, remember for I, as you can see, the predecessors are D and G. The early finish for G is 20, early finish for D is 8. So between 8 and 20, I select 20, and the early finish is going to be 29. Now for K, the predecessors are H and I. So between 45 and 29, I select 45. And 45 plus 15 will give me 60 here. So for L, between 60 and 24, I should select 60. 60 plus 13 will give me 73. So this is my forward pass. Now let's do the backward pass real quick and see if we can find all the late starts and late finishes. So I start from the latest activity. 73 minus 13 will give me 60 for the late start of activity L. So therefore late finish of activity K and activity J would be 60. For activity K, 60 minus 15 will give me 45 as the late start. And for activity J, 60 minus 6 will give me 54 as the late start. Since the late start for K is 45, the late finish for I and H would be 45. For I, 45 minus 9 gives me 36. And for H, 45 minus 11 will give me 34. And then since the late start for I is 36, late finish for D and G would be also 36. For D, 36 minus 2 will give me 34. And for G, 36 minus 2 also gives me 34. Since the late start for H is 34, late finish for E and F would be 34. So I put 34 here and here. For F, 34 minus 16 will give me 18. For E, 34 minus 12 will give me 22. Now, for B, between 34 and 22, I select the minimum. So 22 and 22 minus 3 will give me 19. For C, between 34 and 18, I select 18. And 18 minus 15 gives me 3. And again, for A, between 19 and 3, I select 3. And 3 minus 3 will give me 0. Now let's go ahead. So this is basically the answer to the question, but just in order to finish the question completely, the answer to the question completely, let's calculate all the slacks or activities that don't have any slack. Here you see that A, early and late starts and finishes are equal to each other. So this is a critical activity. Same thing for C. That's a critical activity. You have the same situation for F. That's a critical activity for H as well. I have this situation for K, 60, 60, 45, 45, and finally for L. So I can see that my critical path is A, C, F, H, K, L, and the duration of this path is 73 days. Okay, now let's take a look at question number 4. This is a rather interesting question, a little different from the questions that you have seen before. And it is a very good idea to solve these kind of questions. They will make you more proficient in solving all types of network diagram questions. The tablet unearthed by the archaeologist revealed an ancient culture's project plan. However, the sands of time had erased much of the information that the table once contained. Unlock the ancient project secrets by completing all of the information missing from this fragmentary record. Okay, so now let's take a look at this. You see that we have a table here in which we have activities, predecessors, times, early starts, early finishes, late start, and all the late finishes. But some of these information are missing. For example, for activity C, we don't know what is the duration, what is the early start, what is the early finish, and so on and so forth. For example, for H, we don't know the duration and so on. So much of the table is missing. Let's see if we can unlock this as the question puts it. Okay, so again, we have a copy of the table here, so we don't go back and forth to the question and come back. Let's move this a little down here so we can use this real estate to solve the problem. Let me move this one as well down. We don't need it for now. Okay, so let's build the network together. Okay, so as you see, whoopsie, activities A and B can start without any predecessors. Okay, so this is how I am gonna show. I'm sorry. This is how I'm gonna show the activity A, and the duration for that is 7, and activity B, the duration for that is 8. Then after activity A, activities C and D can be done. So this is activity C, and I don't have the duration for that. Then I have activity D, and the duration for activity D is 11. After activity B, I can do activities E and F. So let me move this B a little down here. I can do activities E and F. And the duration for E is not known, and the duration for F is 11. Then after doing activities D and E, I can do activity G. So this is how I'm going to show it. And the duration for activity G is 6. After doing activity C, I can do H. So this is activity H, and I don't know the duration of that. And after doing activity activity F, I can do activity K, and I don't know the duration of that either. And finally, after doing G, H, and K, I can do activity L, which will take 9 weeks. So this is how I'm going to show that, and it takes 9 weeks. So now let's go ahead and start working on this and see if we can unlock this tablet, as they put it. There are some other pieces of information in this table that we should add before continuing working on this. You see that we don't have any of the early starts, but we have some early finishes. So for example, for activity E, we know that early finish is 17. Okay, so for activity E, we know that early finish is 14. So I take a note of that here. I know that early finish for activity E is 14. And also I know that early finish for activity K is 29. So I take a note of that on the top right. Late starts, I know a few late starts here. For activity C, the late start is 13. So late start for activity C, I take a note of it here. And I know that the late start for activity D is 12. So bottom left corner, I note the late start. For activity E, I know that late start is 17. So I take a note of that here. And for H, I know that the late start is 20. So I take a note of that as well. Okay. And then finally, I know two late finishes. I know the late finish for activity A is 12. So I take a note of that here. And I know that the late finish for activity C is 20. Okay. So these are all the information that I know from this table. So basically I'm on my own from at this point. I need to uncover the missing information. Okay, let's start from the beginning. I know that the earliest start for A and B is 0. Okay, these are the two activities that are basically initial activities, starting activities, and the earliest start for both of them are 0 because they don't have any predecessors, as you can see here. So I can do my forward pass partially at least. 0 plus 7 gives me 7 here, and 0 plus 8 gives me 8 here. So therefore I know that earliest start for C and D is going to be 7. Then I can see that the look at these two numbers. If I look at these two numbers, these late start and late finish for activity C, I see that they are 13 and 20. And I know that in going backward, we know that late start is equal to late finish minus the duration. Now in this case, my late start is 13, my late finish is 20, so my duration is going to be 7. So this is how I can calculate the duration here and take a note of that. So let me fix this real quick, and I don't need this. Okay. Now, what else can I find? So now that I know the duration of C, I can find the early finish as well. So 7 plus 7 gives me 14, and therefore I know that the earliest start for activity H is going to be 14. Okay. Now, for now, I cannot do anything else beyond this point at H. Let's go to activity D. Let's take a look at D. I know that the earliest start is 7 and the duration is 11, so early finish would be 18. And I also know that the early finish of activity E is 14, okay? So between 18 and 14, I know that the early start of G would be 18, okay? So early start of G is 18, 18 plus 6 gives me 24. I know that early finish of activity G should be 24, okay? Also, if you look at activity D, you see that late finish here is 12 and duration is 11. Therefore, my late start is 12 and duration is 11. Therefore, going backward using the same formula of late start equal to late finish minus duration. If you just plug in these values, late start here is 12 and it's equal to late finish minus 11. Therefore, my late finish would be 23. Okay, so this would be 23. So what I need to do is, don't need that. And let me go ahead and add 23 here. So this is going to be my, I lost the circle here. Okay. So this is 23. Okay. So now I know that the late finish here on activity D is 23. Okay. So pay attention here. I know that late finish is 23. I can conclude that late start of activity G was 23 that has been transferred to late finish of activity D. Okay, by the same rubric, I can say that the late finish for activity E as well is 23. Okay, so this part was pretty important. Then, based on this, I have uncovered a lot of information. First of all, on activity D, take a look. The difference between 17 and 23 at the bottom gives me the length of the activity, or the duration of the activity. 23 minus 17 gives me 6. So I know that E has a length of 6, or duration of 6. Therefore, I know that its early start used to be 8. Okay, so 8 plus 6 gives me 14. Okay, now if you look at activity G, you see that I have the latest start, I have the duration, so late finish should be 29. 23 plus 6, or 29 minus 6 equals 23. Now, same logic that we applied to D and G, let's take a look at G and L, okay? You see that the late finish here is 29, meaning that the late start here was, for L, was 29, that has been transferred here, okay? So now I uncovered the late start of L as well. So this is 29. It means that all these three activities had a late finish of 29. Okay, now this gives me a lot of information. First of all, let's take a look at H. Late start is 20, late finish is 29, meaning that the duration is 9. Now that I have the duration, means that I can find the early finish. 14 plus 9 gives me 23. Okay, then take a look at H, G, and K. I have 23, 24, and 29 as the late starts, okay? So among these three, I take the maximum, or 29, and put it as the earliest start of L. Now that I have earliest start of L and I have the duration, I can find the early finish, and I know that for the terminal activity, early finish and late finish are equal. So this will basically give me all the information that I need for activity L. Now let's see what is missing here. For activity F, I can confer that earliest start is 8, okay? Because early finish of activity B is 8, so it would be transferred here and here, okay? And since it is since the earliest start for F is 8, 8 plus 11 for F gives me 19 for the early finish of this activity. Therefore, the earliest start of activity K would be 19, and then the difference between 19 and 29 gives me the duration of K, which is 10. Now, using that same information, I can conclude that the late start of activity K also is 19. So 29 minus 10 gives me 19. Going backward again, I see that late finish of activity F should be 19, and 19 minus 11 gives me 8. Between 17 here and 8, I take the minimum and put it as the late finish of activity B. So late finish of activity B is going to be 8, and 8 minus 8 will give me 0. So basically I unlocked this ancient tablet and found all the numbers. These kind of puzzle-like examples and problems will help you become more proficient in solving these type of network questions. Again, just for the sake of finishing it, we can see that these activities are critical. B is critical, F is critical, K is critical, and L is critical. All other activities, as you can see, have a slack. So we can say that my critical path was B, F, K, L, and the duration of this path is 38. Okay. Now, last but not least, let's take a look at question number 5, which is a crashing problem. This problem says that a 7-activity project has the activity durations in weeks and costs shown in the table. It is possible to speed up every one of the activities by paying a little more. For example, activity A has a regular duration of 7 weeks and a regular cost of 2,000. Okay, so for example, let's take a look at activity A. The normal cost and normal duration are 7 and 2,000, but for $3,000, this activity can be done in 5 weeks. And for $2,500, this activity can be finished in 6 weeks. What does it mean? It means that, for example, for activity A, take a look at this activity. For activity A, it means that the crash duration, the total possible crash duration is the difference between normal duration and crash duration, okay? So number of days that it can be crashed. Let me fix this. So it's crash, number of days that it can be crashed, basically. Is the difference between 7 and 5. So it can be crashed for 2 days, and crash cost per day is a difference between these two numbers divided by the total number of days that it can be crashed. So this time, in this case, it is 3,000 minus 2,000 divided by 2. So it's $500 per day, okay? And we should do this for all other activities. We will get to this in a bit, okay? Now, it says that it adds a little piece of information. It says in addition to the activity costs shown in the table, there's an additional daily fixed cost of $450. What is the least expensive project completion cost? Basically, it says that every day that this project continues, we have to pay $450. So logic here would be that if I can crash this activity at a cost lower than 450, at a cost lower than 450, it is logical to do this, okay? So now let's take a look at it. Again, I have copied the table here so we don't have to go back and forth in order to solve this. Let's first thing that I need to do is to find the crash cost per day and number of days that each activity can be crashed. Okay, so I need to add these two pieces of information to this table. So first is number of days that activities can be crashed, and then crash cost per day. Okay. Now, for activity A, as we just calculated, it can be crashed for 2 days. This is the difference between 5 and 7, and the cost is $500. 3,000 minus 2,000 divided by 2. Okay, so I wrote it the other way. So let's fix that. So it can be crashed for 2 days and the cost is $500. For activity B, the normal duration is 8, the crash duration is 6, so it can be crashed for 2 days again. And the difference between the crash cost and normal cost is $500 divided by 2 would be $250. For activity C, the difference between $2,900 and $2,500 is $400, and the difference between 10 and 12 is 2 days. So it can be crashed for 2 days, and $400 divided by 2, it gives me cost of $200 per day. Then I have activity D, the difference between the normal cost and crash cost is $1,200, and it can be crashed for 3 days from 13 to 10. Okay, so it's going to be 3 days, and $1,200 divided by 3 gives me $400 per day. For activity E, the difference is $1,500 and 3 days, so it's going to be 3 days per day, $500. For activity F, the difference is $800, and the difference in days is 2, so it can be crashed for 2 days at the cost of $400 per day. And for activity G, it is $400 for 1 day. The difference between 6 and 7 is 1 day, and the difference between the costs is $400. So it can be crashed for 1 day at $400. So let's make this a little smaller so it fits with, and let's write down the activity names here as well so there's no confusion. So it's A, B, C, D, E, F, and G. Okay. Now that we have everything, let's go ahead and build the network real quick. Again, you can see that activities A and B don't need any predecessor. So this is my activity A, and it takes 7. I put all the normal durations, obviously. And for activity B, it takes 8 weeks to finish. After activity A, I can do activity C, and that has a duration of 12 weeks. Activity D and E both can start after activity B. So these are the two activities. Since F will start after C and E, I will write E up here, and the duration is 15, and then D also can start right after B, and the duration is 13. So, and then activity F, as I said, starts after C and E. So this is how I will show it, and this will take 10 weeks. And final activity, another final activity basically is activity G, which starts right after D and takes 7 weeks to finish. Now let's go ahead and do forward pass and backward pass to be able to find what activities are critical. So I have 0 and 0 here as the early starts for activity A and B. Early finish here is going to be 7, for B is going to be 8. Early start for C is 7. Early finish for C is 19. Early start for E and D would be 8. Early finish for E would be 23. Early finish for D would be 21. And then between 23 and 19 for activity F, 23 would be early start. 23 plus 10 will give me 33 as the early finish for activity F. And here on activity G, I have 21 as the early start, and 21 plus 7 gives me 28. Now going backward, on the backwards pass, my late finish here is going to be 33, and here also I would put 33. Please pay attention that I'm not using 28. Between these two values, I'm selecting the maximum and putting it for both late finishes. Okay, so 33 minus 7 will give me 26 here, and 26 minus 26 will be transferred here as the late finish for activity D. Late start would be 26 minus 13, which is 13. And over here on F, 33 minus 10 gives me 23. So late finish of E and C would be 23. For E, 23 minus 15 would be 8. And for C, 23 minus 12 would be 11. Late finish for A would be 11 and late start would be 4. Between 8 and 13 here, I take the minimum and put it here. So my late finish for activity B would be 8 and the late start would be 0. Now that I have everything, I can go ahead and find out what activities are critical. B is critical because all the starts and finishes are equal. E is critical, 23, 23, 8, and 8. And also F is critical, 33, 33, and 23, 23. All other activities, as you can see, have slack. Okay, so I build a little table here. On the first column, I have paths. So I list all the possible paths in this network. First path is my critical path, BEF, and the duration of these paths. So duration here is 33. The other path that I can have is ACF. So I take a note of that, ACF, and the duration of ACF is 7 plus 12 plus 10, which is 29. Then I have another path that's possible is BDG, and the duration for that is 8 plus 13 plus 7, which is 28. Now, let's see if I can do any crashing and what type of crashing should I do. Okay. So the duration of my project is 33 and that's my critical path. Okay. I remember that the overhead cost for every day per day was $450. Okay. So if I can reduce the length of the project per day by less than $450, I should go ahead and do that. Okay. First of all, let's take a look at my critical path. My critical path is BEF. Therefore, I should be worried about B, E, and F, these activities. Okay. Among these activities, E is not a good option because the cost per day is more than $450. So my options are F and B. Both of them have a cost per day less than $450. So let's start with crashing B. Okay, so I would crash B, and it can be crashed for 2 days. So I will crash it for all 2 days. And so the cost here would be $500. Okay, so 2 times 250, the cost per day is $250. But at the same time, I save 2 times 450. Okay, so I would save 2 times 450. Okay, and I pay 2 times 250. Okay, therefore I'm saving 900 minus 500, which is $400. Okay, so $400 of saving, and I'm crashing the project by 2 days. So this 33 would be 31, and here ACF will not change, will stay the same. BDG, however, since it has B, will go down by 2 weeks, and it becomes 2 days and becomes 26. Next thing that I can crash is, as I mentioned, activity F, and it can be crashed by 2 days. So I will do the same thing again. So I crash F by 2 days, and the cost here is going to be 2 times $400. So I pay $400, but again, remember, I save $450 per day. So I save $450 per day and I pay $400 per day. So my total saving is going to be 900 minus 800, so I save $100 here. And the length of my project will go down by 2 days. Instead of 31, it's going to be 29. ACF will not change, and I'm sorry, ACF, since I'm crashing F, ACF also goes down. So it's going to be, instead of 29, it's going to be 27 days, and BDG will not change. Now this time, my critical path, as you see, doesn't change, but I reduced the length of the project to 29 days, and I saved $100 here and $400 here. Basically, it's a saving of not paying the overhead cost. Okay, if I do anything else from this point, basically I'm paying more than what I save. You see that all F and B are exhausted. The only thing that's remaining is E, which is costing me more than $450 per day. So this concludes question number 5. That was a crashing activity. This is again one of the most comprehensive crashing activities that you can see again for your final exam, which is a multiple choice exam. This question can generate a couple of questions or a few questions, a few different questions. For example, you can have a question as simple as what is the crash cost per day for activity B, okay? Or it can be what is the maximum possible reduction in the project, okay? So any of these, but again, solving it is going to be as easy as solving the whole network. And be careful about these crash costs and normal costs. Make sure to subtract them and find the crash cost per day or per week per unit of time. Okay, this concludes chapter 14. These videos are all going to be available on Moodle. Please review them and send me an email if you have any questions. We can set up a office hour time via Zoom, or we can work offline via email and make you ready and prepared for your final exam. Again, I apologize that today, because of this technical problem with internet, we didn't have our class. I hope these videos are can be a good substitute for our class. And again, as I mentioned, please reach out if you have any questions or comments or concerns. Thank you and have a great rest of your day. I will see you all on Tuesday for your project.